Hi, this is part 4 of workshop 1. We are continuing the discussion on the Pandas library. I'll provide the code that I will write today in the description section below. We are starting from where we left in the last part. I can even create a new column. Let's say that I want to create a new column named my new call. I will say df1 and then in square brackets I will put the name my new call, then I will write the equal symbol. In the right side I will state what the content of this new column should be. Let us say that I want this new column to be the summation of hello1 column of df1 and hello2 column of df1. We simply state it like this. Now we execute the line. Now let us print df1 and see what is the content of the data frame df1. We see that we have our new column added as the last column of the table. This new column, my new call, contains the summation of the cells of the columns hello1 and hello2. We can do these things using spreadsheet software like Excel. Here we are doing it programmatically. This df1 can have many rows and many columns in a real data set. For simplicity, we only created this small data table. Let's say I want to delete a column from data frame df1. Let's say I want to delete the column hello3. The function to delete is drop. We state df1.drop and then we provide the column name hello3. Let's run this line. Oops. Actually, the drop function expects that a row identifier is provided. There is no row named hello3. That is why we have a key error here. We need to somehow tell the drop function that this hello3 is a column identifier, not a row identifier. Then the drop method will delete the column named hello3. We tell the drop function that this hello3 is a column name by writing this extra parameter axis equals 1. By default, the axis is 0. If I don't mention anything, the drop method will assume that the value of the axis variable is 0. If I explicitly write axis equals 1, then the function will search for the column with the identifier hello3. Then the function will remove the corresponding column, which is column hello3. The drop function is displaying the table that does not contain the column hello3. Let us print df1 again to see if hello3 has been deleted. We find that hello3 is still there even after running the drop function. Therefore, the drop function simply shows how the table would look like if we delete hello3. In reality, df1 still contains the hello3 column. Now, how do we really delete hello3 from our data frame df1? If we really want to delete a column, we have to add another parameter when we call the drop function. We have to state in place equals true. Now the hello3 column will be really deleted from df1. If we print df1, we'll see that df1 now does not contain the column hello3. Why do we have such a parameter named in place for drop operation or delete operation? This mechanism is to assure that something is not accidentally deleted. If someone intends to delete something, she or he needs to write this syntax in place equals true to assure deliberate removal. This parameter in place equals true is a cautionary step. Now we'll see how we can select a subset of the table we have in this data frame. I'll use the iloc function of this data frame. Iloc is a mechanism to use integer positions or indices. In a set of square brackets, I can provide a list of integers indicating which rows I want to select. In the list of indices, I can provide a range like this. Range from 1 to 3. This range means integer 1 is selected, integer 2 is selected, integer 3 is not included in this range function. That is, the first parameter of the range function is the starting integer of the range, and the second parameter is an excluded one. That is, range 1, 3 will return a list that has 1, 2. Range 5, 10 will return a list that contains 5, 6, 7, 8, and 9. It will not include 10. Therefore, this iloc function with range 1, 3 will select rows 1 and 2. That is this part of this table. Here is the output. The column names are provided too in the output. The row identifiers show that rows 1 and 2 are selected. I could even provide a column range. Let's say I want to get column 1 and column 2. I will use a range function. Note that indices start from 0. Therefore, hello 1 is column 0, hello 2 is column 1, hello 4 of this table is column 2, and so forth. Therefore, the modified line should select this part of the table. That is, from row 1 and row 2, it should select column 1 and column 2. That is column hello 2 and hello 4. There are many ways you can select a subset from your data frame as you need for your analysis. I reminded the audience of this workshop that df1 is a data frame. That means you have some metadata around the actual data. This hello 1, hello 2 and the other column names are information about the actual data. These row identifiers are also information pieces about the data. These headers or additional information pieces are sometimes called metadata. Metadata is data about the actual data. To retrieve the actual data without the headers or the metadata pieces, you can use the values field. You can say df1.values to retrieve the code data part from your data frame. Notice that the code data part is an array, which is actually a NumPy array. Generally, we apply our machine learning algorithms on this code NumPy array. As I said earlier, the Pandas library is built on top of NumPy. This is the code data part, which contains the NumPy array. The wrapped around items such as the headers and many other Pandas functions are there to help data scientists analyze and process data. There are many more items in Pandas such as merging, selection, conditional selection. I told the audience that they can take a look at the official documentation for more functions in the Pandas library. Here is the Pandas site. It's pandas.pydata.org. We'll see a few more items of Pandas in the upcoming videos when we will work with scikit-learn's machine learning algorithms. Let us move to the machine learning side of this workshop. There are many machine learning algorithms available in Python. There are many supervised algorithms, there are unsupervised algorithms, there are feature reduction techniques to reduce the size of the data.